Hi, this is Tushar again. So, hope you are interested in the topics we are discussing here. And I'm getting new experiences, and I'm thrilled to like share the thoughts with you. So, in the last video, we discussed that yes, how much the charge can be and the current capacity of the lightning. So, as per the standards, we are going with. Should I disclose it now? No, I will disclose it later. Okay. So, considering that if the amount is high, that is obviously lightning is a high charge conduction. So, after that, what are the effects it can secondary effects it can cause to any of the equipment or circuitry? It it can be EMC. First is the EMC, electromagnetic conduction. So you will not get to know that yes, that lightning is going on from a particular conductor which you have considered for lightning. It is going from the out of the structure, but you have some kind of wiring which is going beneath that structure, or you can say beside that particular conductor. You have a wall, but you know that any charge carrying conductor will have an electromagnetic field, and it depends upon solely on the charge which is flowing in that particular conductor. We have in the like in the our school days we have studied that's mutual induction. So the wire is going on, the semiconductor is beside that, and the charge which is flowing, if it has a high density of current is there, so it will make a magnetic field around it, which will try to induce a current in the opposite conductor also. So we have to protect the rest of the equipments because they can be sensitive, the charge, they can be sensors, they can be false alarms because of that, they can be data sharing center and data's sharing cables for data centers, they can be any kind of wiring which has not been shielded, they cannot be having the insulation to withstand these type of opposite current which can heat up. So these all things. So what do you think the basic calculations for the lightning designing for LPS or systems? So for that, IEC 62305 is a standard which tells us how to install, what are the basic credentials, what are the point of considerations before and after the installation of the system, how we have to place each and everything is stated. IEEE 81 is there, which helps us to calculate the ampacity, what will be the step potential, what will be the skin depth, what is the like you can say the faults, will it be capable to handle the faults current. Obviously if the conductor is capable to handle the lightning current, it will be able to handle the faults current because it is way less than the lightning current, but still these all types of calculation which are very necessary to be done, which like in these calculation we go with what is the material we are using, what is the resistivity, what is the soil resistivity, what is the TCAP constants, all these things. So if you want that I should like help you or acknowledge you with those types of particular calculation, I can help you. I can make that, but if it is specific I can help you with that also. So but I think these are the things which we have always been there. I still remember there was a small topic in my graduation where how the lightning is, what the lightning calculations are. Simply small sections were there, but considering that there a vast topic which has an effect because of this. In the last section also I studied that there are the majorly I'm considering substations are there, because substation and the buildings which are higher than 80 meters, you can not predict that the lightning is not an obedient student. It will fall wherever it likes. It's a stubborn thing, it will happen, you cannot protect it, but you can get your structures out of the vulnerability. This is the only thing you can have, that's the nature. You cannot run against the nature. So but you can protect yourself that it should not damage. So the lightning, if it is striking now, so it will not only strike on the top, it can give a side stroke also. It can damage you from the side also. If you are considering that yes, I have a building of such like 220 meters, and you will consider that no, the lighting will be my top portion is protected, my whole body structure is protected. No, it's not like that. So as per the standard, if you say 20% of the total height, 20% of the total height, you calculate that, and you measure the height from the ground, only that portion you don't need to get a side protection, but above that you need the protection from the side strokes also. How we have to protect, what kind of conductor you can use, which kind of fencing you can make, how you have to lay down the conductors, these are all very interesting topics. So considering these things, the second thing I want to discuss that in the next few videos I will come up with the EMC standards also, that are the electromagnetic conduction, in which how the system needs to be protected, what are the dangerous hazards of the EMC, what are the precautionary things we have to consider, what are the points to be considered to make the metals or plastic or concrete, whatever, how to decide whether your concrete structure is well enough to handle the EMC. And also if you can tell that which kind of structures or which kind of facilities specifically are more vulnerable to EMCs, because EMC doesn't come from the specifically from the nature, it will come from the man-made facilities which are around your particular site. How you have to calculate it, okay, we will discuss these things in the near future. Whatever I will come up, I will know, I like to share my thoughts with you, and I will share whatever technical knowledge I can share with you, because industries is, we know, we learn, we share. By this only we can grow. Hope I am getting some kind of like acceleration in your knowledge. So please help me with this. And now again coming to the topic, that how much the current we are considering in the standards. Now the standards, all the authorities throughout the world are considering 200 kilo amps of the current. This any of the lightning protection system which is capable to handle 200 kilo amps will be considered optimum and feasible and acceptable by all the authorities throughout the world. Hope you get some knowledge and you are doing good. So enjoy and please subscribe. Thank you.